Greetings all. Today's demonstration is a favorite when I do science shows at our local schools. It's the exciting redox reaction of copper and silver nitrate. Well, as a chemist, it's exciting for me. This reaction will extract pure metallic silver from a salt. The name of that salt is silver nitrate, and silver is part of the compound. Silver is number 47 on the periodic table and has the chemical symbol of Ag. Ag derives from the Latin word argentum, which is based on the root arg, meaning white or shiny. And indeed, silver is definitely shiny. In fact, it is known as the most reflective of all the elements. This proof is composed of 99.9% pure silver. As I mentioned, silver nitrate is a salt. A salt is a chemical compound consisting of an ionic assembly of positively charged ions, or cations, and negatively charged ions, or anions, which results in a compound with no net electric charge. Of course, an ion does not have to be just a single atom. Polyatomic ions are ions composed of two or more atoms, just like the nitrate ion that we are looking at in today's demonstration. A nitrate ion is composed of one nitrogen atom and three oxygen atoms. Together, they comprise a single ion with a charge of -1. Silver nitrate looks very common like a lot of other salts. You will notice that it looks very much like the salt that you put on your food. Table salt, as it is commonly referred to, is sodium chloride, or NaCl, or one sodium atom combined with one chlorine atom, much different than the silver nitrate, which is one silver atom combined with a nitrogen atom and three oxygen atoms. Yet they look very similar, though you would never want to salt your fries with silver nitrate. To begin our experiment, we need to expose the copper on a 16 gauge wire. Then we need to sand the wire to ensure that we have a clean surface so that the reaction proceeds at a quick pace. You can see the difference between the slightly oxidized copper compared to the clean sanded copper. This is the test tube that we will be performing our reaction in, so we need to do a rough measurement of length and diameter for the copper wire. Perfect. Now we will add a solution of silver nitrate. And our copper wire. And watch the reaction take place. This reaction took over 16 minutes to get towards the end of completion, so I sped up the video. Besides, I think it looks a little cooler this way. You can see the fuzzy and hair-like strands of silver building up on the copper wire as the reaction proceeds. You will also observe that the solution is turning from colorless to a nice blue color. This is because the silver nitrate solution is slowly being converted to a copper nitrate solution, and copper nitrate is blue. This is copper nitrate in its solid form. Recognize the blue color? The fact that the solution is turning blue is also an indicator that a displacement reaction is taking place. In this case, a single displacement reaction, which is also known as a single replacement reaction. What does this mean, you might ask? It means that one element is going to trade places with another element in a compound, or one element is going to replace another element within a compound. In our experiment, copper is going to replace or displace the silver in the silver nitrate compound, and a new compound will be formed. That new compound will be copper nitrate. For those of you that know your stoichiometry, you will notice that this is an unbalanced equation. We will balance this equation shortly, but before we do, notice the symbols that denote the physical state of the reactants. The AQ denotes that the substance is in an aqueous state, or a liquid state that is dissolved in water. The S denotes that the substance is in a solid state. In this reaction, the copper is in its solid metal state on the left side of the equation, while silver nitrate is dissolved in water and is in an aqueous state. On the right side of the equation, the silver is in its solid metal state, while copper nitrate is in an aqueous state. The two metals not only traded places within the nitrate compound, but they also traded physical states. Isn't chemistry cool? Now to balance this equation. Remember the law of conservation of matter. Matter is neither created nor destroyed, so we must have the same number and kind of atoms after a chemical reaction as were present before the chemical reaction. That's basically what balancing is all about, making sure that all the atoms add up on each side of the equation. First, we will add 2 units of the silver nitrate compound on the left side of the equation. Then we'll add 2 atoms of silver on the right side of the equation. The 2 units of the aqueous nitrate molecule was already noted in this equation. Now the equation is balanced. There are 2 units of silver on each side of the equation. There are 2 units of the nitrate compound on each side of the equation. And there is 1 unit of copper on each side of the equation. Again, matter is neither created nor destroyed during a chemical reaction. Atoms and molecules just rearrange during a chemical reaction. If you want a more detailed explanation of balancing equations, please leave a comment below and I will create a future video that I will post on this channel. Now, to put a visual to what I just explained, the test tube with a copper wire and the colorless solution are what the left side of the equation represents. The copper in its solid state and the silver nitrate solution in its aqueous state. The products on the right side of the equation will start to be formed once the reaction begins. We start with reagents on the left side of the equation and end up with products on the right as the reaction progresses. The silver metal is the gray, fluffy looking solid that forms around the copper wire over time. Here's another visual example of this reaction through animation. The copper on the left side of the equation is represented by the stack of orangish colored copper atoms labeled Cu in each atom. This is the copper wire. The silver nitrate solution on the left side of the equation is represented by the white atoms labeled Ag and the molecules that are labeled NOOO. This is the solution in the test tube that surrounds the copper wire at the beginning of the reaction. Though the silver atoms separate or disassociate from the nitrate molecules in solution, they are both still part of the silver nitrate solution. We'll talk about the disassociation of salts in more detail in a future video. The silver ions react with the copper metal and release a copper ion into the solution that replaces the silver ion with the copper ion within the nitrate solution, thus converting the silver nitrate solution into a copper nitrate solution. The copper ions are blue in this animation, just like copper nitrate is blue in solution. The silver ions become silver metal on the right side of the equation and is precipitated out onto the copper wire. The silver metal is represented by the gray colored atoms marked Ag. The copper nitrate molecule on the right side of the equation is blue in color. You can observe that the blue color gets darker, meaning that the copper nitrate solution increases in concentration as a reaction progresses. If you watch carefully, you will notice that it takes 2 silver ions to react with 1 copper atom before 1 copper ion is released into the solution. Stay tuned for a future video where we will talk about ions and charges during reactions. Thank you for watching this video. If you think that something needs more explanation, or you would like to see another subject covered, please leave a comment below. And of course, if you like this video, please give a thumbs up, share the video, and subscribe to this channel for more science videos in the near future.